Hello guys, I'm Shagnik Das, a first year computer science engineering student at Sri Venkateswara College of Engineering, Bangalore. Today, my topic of presentation is computing error and approximations, and the subject is Mathematics 1 for CSE stream. Computing error and approximation. This presentation explores the fundamental concepts of computing error and approximations. We will delve into various types of errors, their sources, and methods for analyzing and mitigating their impact in numerical computation. Introduction to error and approximations. Error in computation arises when a computed value differs from the true or exact value. It's inevitable in numerical computation due to limitations in representing real numbers and performing operations on them. On the other hand, approximations are used when obtaining the exact solution is infeasible or computationally expensive. They provide estimates that are sufficiently close to the true value for practical purposes. Absolute and relative error. Absolute error is the difference between the approximate value and the true value. It represents the magnitude of error without considering the relative size of the true value. On the other hand, relative error is the absolute error divided by the true value. It represents the error relative to the size of the true value, providing a more meaningful measure of accuracy. Significant figures and rounding. Significant figures represent the number of digits in a value that are considered reliable. They indicate the precision of a measurement or calculation. Rounding is a process of approximating a number to a specific number of significant figures. The choice of rounding rules depends on the desired level of accuracy and approximation. Truncation error. Truncation error is the difference between the actual value of a function and an approximate value. It occurs when a function is approximated using a finite number of steps instead of the actual value. Infinite series. Some mathematical functions can be expressed as infinite series. Truncation error arises when we approximate this series by taking a finite number of terms. Approximation. The more terms we include in the series, the better the approximation. Truncation error is the difference between the true value and the truncated approximation. Discretization error. Continuous functions. Many real-world problems involve continuous functions. To solve them numerically, we often approximate the function with a discrete set of points. Discretization error is the difference between the true value of the continuous function and its discrete approximation. It's influenced by the spacing of the points. Round-off error. Finite precision. Computers use finite precision to represent real numbers. Round-off error occurs when a number is rounded to fit within the limited precision of the computer's representation. Accumulation. Round-off errors can accumulate over multiple calculations, leading to significant discrepancies between the computed value and the true value. Propagation of error. Error in inputs. Error in inputs values can propagate through computations, amplifying or diminishing their impact depending on the operations involved. Error analysis. Error analysis techniques help quantify the propagation of error and determine the overall uncertainty in the computed result. Error analysis techniques. Sensitivity analysis measures how much the output changes in the response to variations in input values, providing insights into error propagation. Part Perturbation analysis. Perturbation analysis involves introducing small changes to input values and observing their impact on the output, providing a quantitative measure of error propagation. Monte Carlo simulation use random sampling to estimate the distribution of errors, providing a probabilistic approach to error analysis. Applications of error analysis. Scientific computing. Error analysis is crucial in scientific computing to assess the reliability and validity of numerical models and simulations. Engineers use errors analysis to design and analyze structures, systems, and components, ensuring safety and reliability under various conditions, which falls under the point of engineering design. Financial modeling. Error analysis is essential in financial modeling to assess the risk and uncertainty associated with financial forecasts and predictions. Example on a code, there is an example on the left side, and the explanation is as follows. This example demonstrates how to approximate pi using the Monte Carlo method. We randomly generate points within a square and count the number of points that fall inside a circle inscribed within the square. The ratio of points inside the circle to the total number of points approximates the ratio of the circle's areas to the square's areas, which directly related to pi. We calculate the absolute error by subtracting the approximated value from the true value of pi. Output. The approximated value of pi will typically be close to 3.141592653589793, and the absolute error should be small, on the order of 10 to the power minus 3 or less, depending on how many iterations n are performed. In this case, since you are using 1 0 uh, 1 lakh iterations, the error should be relatively small. Summary. In computing, errors and approximations are inherent due to limitations in precision, hardware, and numerical methods. Key points include rounding errors occur when numbers are rounded to fit within a finite representation, leading to small inaccuracies that can accumulate in calculations. Truncation errors result from approximating infinite processes like series expansions or integrations by finite steps, leading to incomplete results. Floating point representation. Numbers are often represented in a format with limited precision, causing minor errors in calculations that can compound. Algorithmic approximations. Some algorithms, such as those for solving equations or optimization, inherently involve approximations that may not provide exact solutions but offer close estimates. Accumulation of errors. Small errors can accumulate in iterative computations, sometimes causing significant deviation from the true result. Error control. Methods like error analysis, tolerance levels, and convergence checks are used to manage and minimize the impact of errors. In summary, computational errors and approximations are unavoidable, but careful management ensures results are sufficiently accurate for practical use. Thank you. Thank you for your kind attention.